that has this kind of thing. So what I want to talk about is the history of this thing and how it came about. And not just this, you've actually been doing it ever since. Let's say, let me write on my peers here. They are, all the while we've been creating our list, we used to write something like this, a list of integers and then let's say call it a list and new array list. So this kind of thing, we'll be doing it all the while. So what we're covering today is why, give me a second, I would, okay, let me import my list. Explain why. For you not to have asked me, I'm assuming that maybe you know why. Why am I not writing this like this in short? Int or double or the other one float and the rest or character. Why have I always used that big capital letter one? Since none of you asked, so I'm assuming that you have an idea or you know. Could anyone come up with an answer? Any answers? Any answers? Any answers? Any answers? No answers? Okay. Okay, so the thing here is this particular thing that we specify here, it has to be a class. And when I say class, it has to be a type of, it has to be an object defined in Java. So integer is an object defined in Java. Double is an object defined in Java. Float is an object defined in Java. This even generic demo you're seeing here, just by naming a class like this, it can be an object can be created out of it. So we can have this kind of thing, generic demo. So this is a class defined in Java, but we can never have an object out of this, because all of these things are primitive types. That's not to say these ones cannot act as primitive type, but they've been modeled such that they can act as print numbers. Say, okay, Bukola, welcome. Say, say one, two, 2 point. So all those things are the primitive type of numbers. They are not objects. They are not objects. So that's why we cannot specify this kind of thing here. Say double or int or what else, or float. We can't specify those kind of things here because all they do is to, should I say, accept value. They don't behave like objects. So look at what we're talking about is why we have generics, why we create these kind of things in Java. Say we create a list of, let's say, now come here and specify integer. So I'm saying we can't specify the small letter integer like this, or sorry, int. We can't specify it like this. Normally we can have something like int a equal to 1. It's possible to also have something like integer b equal to 1. Let me just keep it like this. So these things will behave the same to some extent. The difference is that, see, if I right click this one, if I try to go and see what's documented inside of this thing, you see it's not going. In fact, it's a keyword because it's labeled, it's colored orange like this or that one. It's a keyword, in fact. It's not a class. But for this one, if I try to go inside it, it should lead me somewhere. And that's because it has been created, it's a class. So this is basically what I mean, or the one I've been saying is a class. They created a class called integer with capital I. You see? So they created a class called integer. They also created a class called double and the rest of them with capital D and the so these two can behave to some extent. You know, objects can have the value of null. Objects can have the value of null. That's why some places you may see integer z equal to, it has the value of null. But if you try something like integer int y equal to null. It's not possible because this is of type primitive. So this is more like a keyword to tell you that what's coming here is of type integer, and it can only accept value from that within the range of integers basically. But this one, not only can it behave as an integer, but it can also behave as object. Object basically is that instance created out of a class. So it's possible to have an object that is equivalent to null. So that's what this thing means. Is it clear so far?
Yeah, thank you.
Okay, so that is that for that. So because this is more like a keyword that specifies that is actually of type integer, we can't use it in places like this. But instead, we use the class type of it. So if you do it like this, everything is fine. So this thing you're seeing here is a class or object, whatever. So so that is it for that. I mostly use integers. That's not to say you cannot use other types of object. String is an object. Which other one? Even this class name you're seeing here, generic demo. Just by doing it, I can create object out of it and paste it here. And things are still good. So I can actually create instances of these things and then store them inside of this list. That's basically what I've been talking so far. So let's say I have this one loading to an integer. So I'll keep it this way. So what I'm trying to demonstrate today basically is why we have these kind of things, angle brackets. So let's say for example, um, mm, what can I say? What can I say? Okay, let's say we have a class called, let's say we have a class called doctor. Doctor. Let's say we have a class called doctor. So what I can do is to come here and say, what can I say? What can I say? Okay, say string, say profession, and then I have my constructor, public um, doctor, let's say it takes in the profession, right? And let's say this dot profession equal to profession, and let's say create a we want to create a method that prints profession. Let's say it returns nothing. All it just does is to print profession. Come on, now. So let's say the profession is the profession. All right. So let's say the profession is whatever I pass in here, and then let's create another class. Let's create another class called let's call it engineer. Let's say engineer, right? Then this one should be engineer. So what I can do is to come inside here, and what I'm working with is engineer, not doctor. Okay, so we have this kind of thing now. We have two of them. We have engineer and we also have doctor. If you look, you can see that these two codes basically are similar, and therefore we could decide not to repeat our code up to this extent. So we could make use of the idea of generic. And what we could do is just to create a class that could perform the action we're trying to do in the two classes of doctor and engineer. Let's say this class, we will now call it profession. We now call this profession. And then, now this is where that diamond bracket thing comes in. This is where the diamond bracket thing comes in. So we could have something like, okay, we could have something like this. And okay, basically anything that is inside here could range from A to Z, capital A to Z, but it's a common practice to use T. Basically, what T denotes is type. So whatever type is going to be passed here, represents the object that is working with this class at that point in time, basically. So if you come into the doctor, we have so this thing you're seeing here is a type string. Basically, any class that you use is a type. That's what I'm saying in essence. I wouldn't want to drag it. So what we could do is to create a single class that will account for this code we've written here, as well as this code. Come to the doctor, this code we've written here. If you look into the two of them, this is for doctor and this is for engineer. They are quite similar. And we want to eliminate it. So what we could do is to use the concept of generics basically, and tell it that it should accept any type of this thing you're passing, whether it's a doctor or an engineer. So what you could do is to have string and then profession, all right. And then we could also have of course we have a constructor. We call it profession. And it takes in string name, and then this dot profession equal to name. So if you now come here, what you could do is what I'm trying to replicate now is, if you come into this thing, I want to print this particular thing you're seeing here. So what we could do, okay, should I make this? Okay, let me make this to return return something, because it's by returning something that this thing is going to explain better. Say I want to make it to return a type of engineer. So what I could do is to return this and this. This was profession. Okay. Engineer. All right. So this also will be engineer. All right. So I'll do similar thing here. I'll do similar thing here. So this is going to be of type doctor still. This one also will be. There's actually more to generics, but you wouldn't need the deeper aspect.
Sorry, I didn't hear what you said. Good evening, everyone.
Yeah, how are you doing? How are you doing, Bukola?
Thank you.
Yeah, I was asking if you submitted the last assignment.
I'm still on it.
Okay. Please, if you can, do where to submit it today. So I'll just be extending it to 12 a.m. Right? So I'm taking that as a yes. All right. So I will be accepting any question based on what you've done this week. I think this is just what I wanted to mention. And then, since you've not all submitted your assignment, I can go ahead to demonstrate how to do it. Do you have any question based on what you've done this week so far?
Go ahead. We like it.
Huh?
You can go ahead
And do what?
and demonstrate with the assignment.
When you've not even submitted. How is that possible?
It will not help us,
I'm not doing that. No, I'm not doing that. Some of you have actually submitted. Some of you have submitted. So if that's possible, then the rest of you should be able to do it since you come to the same
The
class.
question I wanted to ask is, you said we should create an alien class.
Huh?
So, are we after the alien class? Are we going to also create another class, or is just going to be just two classes, the main and alien class?
Yeah, it's possible actually to do everything in one class. It's very possible. But it's also possible that you can break it up into multiple classes. Anyone that suits you best.
Okay.
So the other thing which we didn't cover in our lesson is array. Array. So just array. That's something we didn't cover. Array basically behaves in a similar manner as array list, but there's a slight difference. Or maybe it's even much. It's much. It's much. So how array works is that you have to specify the size. So the array is the, should I say it's a more rigid way of creating a collection. It's a more rigid way of creating a collection. In collection you can do, you can add as many items in the array list as you like. But when working in array, basically this is an array. This thing, the way I've represented it, is telling it that I
So,
want to. Yeah, I have a question.
no, I just want you to comment on that on the array. Just comment it
Have you come
so
across
that
it?
it will be easy.
You say I should comment
Huh?
it or I should comment on it?
Like yes, array, so that we'll know that part is array.
Okay, okay. Like this, bar.
I've come across it. Yes.
Okay. So basically, how array works is it works similar. You can think of it as similar to array list, although there's a difference. And like I said, it is more rigid. In array list, you can manipulate information as you like. Basically, you can add as many as you like. You can remove. You can perform different methods with array list or linked list or vector. All of them, all those ones that implement the collection interface. But array is rigid in the sense that when you're creating it, you have to specify the amount of elements you're going to be putting in it. And you cannot reduce the size of that array list. But what you can do is to reassign it to another array list basically. You can reassign this thing to be pointing to another array list. But that's what I'm doing now. So I'm trying to point out that once you specify the size, you work with that size. You can't put in more than two items in this array list. If you create it, you tell it the size. You can tell it five or any amount of items it can accept. Not only can you have, so by doing this, and I'm specifying that this is an integer array. Integer array. I can actually have a string array. Let's say string array, and tell it. Sorry, this should be string, and then tell it the size of items that I want to be passing into it. So basically, any object you can have it array. I can change this actually to become integer, but there is also a difference as to there are some things which this one can do, the other one cannot do. So I can have this integer array, I can have string array, I can have character array. Let's say, let me call it C. So it's not a must that you can just you specify how many elements is going to carry. You can go straight up and assign and passing the elements as you're creating it. You can go straight up and passing the elements as you're creating it instantly. Otherwise, you can just create it and tell it that it's going to accept a particular number of elements. Then later in the future, you can assign those elements. Is that clear? So this is one way of creating a character array. This is one way of creating a character array, and this is the element that's going to be carrying. You observe that I didn't specify the amount of elements. That's because I'm passing in the elements straight up. So this is one way of creating an array list. The other way of creating array of characters. The other way is to use the new keywords, and everything still works the same basically. But the other way, that's this way, is the shorthand. But they're still the same thing. So this is one way. So this is another way, as you're seeing it here now. So as you've created all of this, to assign a value to a particular index, you know, in array list, you do something like add. You add, then you add whatever you want to add. If you want to add in a particular index, you specify the index, say index 1, then the element you want to add at that particular index. So this is one way of doing the array list something. But here, if I want to add an element to say index 0, how to do that is say int array, because it's an array of integer. And at index 0, what am I assigning there? I'm assigning 1. Or say I'm assigning 30. So this is how to assign elements into an integer array. So if you go to my index 0 now, what I will be seeing is 30. 30, and by default, when you create an integer array, the value there will be 0. So basically at this stage, it is 0, 0. Okay, there are 5 elements to accept. 3, 4, 5. And by doing this one, what I've just done is to say this is 30 and this is 0, 0, 0, 0. Okay, so if I wanted to assign a value to the, this is 0, 1, 2, 3, 4. If I wanted to assign a value to the 4th index, what I could do is just this. So I want to assign 50 to the index. So if I do this, what would become of my assembly? I'll copy this. So it's going to be something like this. So this is for integer array. So this is how you work with arrays basically. Arrays don't have many methods.
I'm sorry, I am a little lost. Is array different from array list, Abby?
They are different. That's what I'm
Yes.
saying.
Oh,
Arrays are more rigid. They don't give you the flexibility that array lists would give you normally. Do you understand?
I saying array. I thought you were talking about array list.
No. I was saying it all the while. So arrays are more rigid. They don't give you flexibility. One of the main features is that to create an array, you create it and specify the number of elements is going to be accepting. In this case, it is 5. Or if you don't want to, or if you want to assign the elements straight up, you do it this way, and you don't have to specify the number of elements is going to be accepting. So typically, this one accepts 3 elements. I can go ahead and just keep adding more elements as I like. But if you don't want to assign it straight up, you do it this way. I've done it. But for most of the time, what you'll be working with, okay, I think the usage actually varies. Now, but many cases, what you see people using is the array list, and that's because of the flexibility. Although it consumes more computer memory, but there are situations where you will not have to use it. You make use of the array. I don't think I'm missing any. I mean, if you've opened the GitHub account and code was,
I had one. I had one
which of them? GitHub.
for GitHub. I had them.
Okay, you already have the GitHub account.
Yes.
Okay, what about code was?
Not yet, but I'll do it.
Okay, okay, that's fine. So the good thing about this code was is it makes you get more acquainted with the syntax and the possible method that are attached to each data structure, hash map, and the rest of them. The different methods that can be used in it and how they work. So when you use them to solve, say, algorithm, it forces you to check out things because you have to browse online on how to do a particular thing. And that's just how you get acquainted with programming. I feel like I'm missing something, although I can't remember. Can't remember.
You said you will explain or you teach us how to upload that Git hub, how to upload our code there.
Okay, I actually want to do that, but I don't know if it will be in this class. I'll share a video. Instead of making this lesson longer, I'll just share a video. Then if you have, it will actually put you through how to do it. But if you have any question, we'll take it from there. You can do that personally. If you have question, you can ask me. But there are resources online on how to do that. Do you understand? Do you understand?
Okay.
Yeah, so we don't elongate this class. What am I missing out? What am I missing out? What am I missing out? Okay, that will be all. So we see when? We see whenever we say.